Yeah. Yeah, good afternoon. So myself, I'm Vijay. Like I hold nearly 17 plus years of experience, which includes nearly 8 plus years of experience in Python, in Hadoop and Spark environment, right? So as part of today's demo, I'm going to cover the following topics, right? What it's a big data, Hadoop and PySpark we are going to cover. Spark with Spark with Python implementation and Hadoop. These two things will be covering, right? What is big data and why Hadoop? Drawbacks with current databases and advantages of Hadoop and Spark. And Hadoop and Spark job market today, right? Yes. So big data. What is big data? The name itself saying like huge volumes of data. So how the data is getting stored currently, right? KBs of data, MBs of data, GBs, TBs, petabytes of data, exabytes, zettabytes, etabytes, ottabytes, right? So should have seen KBs, MBs, GBs, or TBs. But petabyte of data, is it getting generated in the current world? Means yes. Petabytes of data, is it getting generated? Means yes. 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit. So right. So examples for petabytes of data generation. Examples of petabytes of data generations means, right? Like if you talk about social media like Facebook, right? Millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? What should be the storage capacity to store all the posts and videos? What is the data generated by Facebook in a minute? Right, huge data, right? So 1 second. Not only Facebook, today if we talk about any application generating huge data, if you take 1 minute transaction, in a minute, how many FB posts? In a one minute, how many Facebook posts? Twitter tweets. Google queries. And everyone creating their own videos, right? YouTube videos upload. What should be the storage capacity to store all the videos? Millions and trillions of users using email messaging, right? And what is the storage capacity to store all these messages, right? And if you talk about the bank transactions, if you take example of any particular bank like SBI or HDFC, right? Within the city, we see thousands of branches. Within the entire state, we see lakhs of branches. Within the entire country, millions of branches, right? Yes, again, in each branch, like we have got multiple customers, each customer making multiple transactions per day, per week, per month, per year, right? Each and every transaction has to be stored, huge data, right? It's similarly like telecom transaction. And if you talk about the e-commerce sites like Amazon, Flipkart, all this, right? Generating huge data. Everywhere we see like huge data, right? Yes, currently we have got databases for storing the data, right? Databases like Oracle, MySQL, DB2, SQL Server, right? They're used for OLTP, online transactional processing. We have got some specialized databases like Teradata, Netezza, Vertica for data warehouse purpose, right? If you talk about this, databases are specialized databases. They are used to handle certain they are used to store data up to certain extent, right? But Huge data or unlimited data storage is not possible in this, right? Huge data storage, unlimited data storage, and that too they can handle. They can store only structured data, right? But today, if you talk, we are it's in the current real world. Most of the data what we see is unstructured format. If you see the data generations, right? How the data is getting generated. Data, right? If you talk about this is the data from the last 50 years, which got generated from last 50 years from 1973 to 2023, right? Yes. If we compare this data from the last 10 years, like 2013 to 2023, previous last 10 years data with the previous 40 years, right? But especially 80% of the data what we see in the current world has been generated from the last 10 to 15 years, right? The reasons for huge data generation, right? Because of usage of technology, because of usage of smartphones, usage of internet. Today, everyone carrying internet, right? In 1990s or the earliest stages of 2000, right? The data storage units like we see like floppy disks, CDs, DVDs, right? In MB subjects. Floppy disk 1.4 for MB was the size, right? So what are the main sources from where this data is getting generated? Mainly three sources of data. Mainly three sources of data. Social data, machine data, and the transactional data. What is that? Social data, machine data, and transactional data. The data which got generated from the social sites, right? Like WhatsApp, Twitter, or this Facebook. Machine data means the data which got generated. The data which got generated. The data which got generated by reading or scanning the barcodes, RFID chips. Such kind of data we call like machine data, and transactional data from day-to-day activity. Data which got generated from day-to-day activities, right? Okay, mainly three sources of data. And the types of data. What are the main types? This data is of mainly of three types. Three types of data. Structured data, semi-structured, and unstructured. Structured data means data which is organized in the form of rows and columns. Data which is organized in the form of rows and columns. In a structured format. Data which is organized in the form of rows and columns in a structured format, right? Like DB tables, database tables, Excel sheets, Excel sheets. Right. Semi-structured means which is not fully structured, which is not fully unstructured, right? Like XML files, JSON files. Unstructured data like articles, images, videos, articles, images, videos. All this, right? Unstructured data, short messages, articles, images, videos, files. But most of the data what we see today is of unstructured format. So the most challenging is like how to store and process this kind of unstructured and semi-structured kind of data, right? So there's, but if we talk about the current databases can handle only structured data, so we go for a framework called Hadoop, which can handle all varieties of data, and that too like unlimited data storage and unlimited data processing, huge data storage and huge data processing, right? Yes, three sources of data, right? I discussed social data, machine data, and transactional data, and structured, semi-structured, and unstructured. So to overcome all this, to overcome, right, all the storage level problems, right, we have got a framework called Hadoop. We have got a framework called Hadoop, right? So yes, Hadoop is meant for two things. Hadoop is meant for two things. For storage and for processing. Hadoop is meant for storage and Hadoop is meant for processing. Hadoop is meant for storage and processing. Hadoop performs both storage and processing. For storing the data, right? Storage and processing, for storing the data. Okay. So if you talk about any technology like C or C++ or Java, all this, right? Or Python, all this, they are used for processing. And if you talk like Oracle, MySQL, DB2, SQL Server, all this, they are used for storage. Means any technology is meant either for storage or processing. But Hadoop is meant for both storing and processing. Hadoop is meant for both storage and processing. For storing the data, does Hadoop use any database internally for storing its data? No. Databases has got some drawbacks. Despite of this drawback, still Hadoop doesn't go with any databases for storing its data. So it's going with a special kind of file system called Hadoop distributed file system. And for processing, it is going with an execution model called as MapReduce. Currently, we are going with an execution model called as Spark. Very high speed processing called Spark. Huge data within quick time, in minutes and seconds, it is going to process, right? So Hadoop is meant for two things, for storing and processing, right? For storage, HDFS, and for processing, MapReduce. Right. Okay. So, and one more thing, you may ask, when Hadoop is able to do both storage and processing, what is the necessity of this processing technologies and storage when it is able to do both? Do you think when Hadoop in the market, these technologies will be away from the market? You need to understand carefully, right? Hadoop is good for huge data. Hadoop is good for huge data. Hadoop is bad for small data. Means for Hadoop is meant for batch processing. Hadoop is meant for batch processing. For one record or one transactions, two transactions, we don't go for Hadoop, right? For millions and trillions of transactions, right? We go for Hadoop, right? We have got two types of public batch and online processing. Online applications or batch applications, right? Observe this. Hadoop is meant for storage and processing. For storage HDFS and for processing MapReduce or Spark. Hadoop is not for online processing or online applications, right? Because if single transaction, we won't go for Hadoop. So Hadoop is for batch applications. There are two types of applications: online applications and batch applications. Online applications and batch applications. Online applications, user interactive applications. Here user gives the input. Here user gives the input. Booking a movie ticket, making your online transaction. These are examples of online applications, booking a movie ticket through online, making an online transaction, all this, right? And batch applications, right? User non-interactive applications, Here user is no way required. Here user is no way required. Means, for example, railway ticketing PNR status, right? Railway ticketing PNR status. Means your waiting status is 200 now. After 2 hours, it is 150. Tomorrow morning, it is 100. Tomorrow evening, and tomorrow morning, it's 100. Tomorrow evening, right? You got the ticket, got confirmed. Means this is happening without the user interference, right? Here it's happening within the background, right? Here user is no way required. And for example, for credit card statements, for credit card statements for millions of customers, right? The batch application for millions and trillions of for these people, customers, right? Credit card statements generation, phone bill generation, right? Mobile bill generations, right? Statements generations for millions of customers. Okay. So for this batch applications, right? Credit card statements for millions of customers, user interactive applications, right? Yes. So Hadoop is meant for batch applications. It's not for online application. If Hadoop wants to perform online application, we are going to integrate Hadoop with NoSQL database, where NoSQL can handle online applications when Hadoop is for batch. Combinedly, both can perform both batch and online, right? Yes. Why databases like Oracle cannot store Hadoop's data? Why databases like Oracle cannot store Hadoop's data? Why databases cannot handle this data, Hadoop's data? Drawbacks with the current databases means, firstly, limited storage, right? In GBs or in TBs. Limited storage in GBs or in TBs. And secondly, most of the databases, no parallel processing, we are going to see that. No parallel processing. Yes. Yes. And thirdly, as volume increases, speed decreases. If volume increases, speed decreases. Means, for example, if you take a query, SQL query like this, volume increases, speed is decreasing. If the query is like this, observe these 3 queries. I want the sum of amount from sales 1. I want sum of amount from sales 2 table. I want the sum of amount from sales 3. I want the total amount from sales 1, total amount from sales 2, total amount from sales 3. Total amount from sales 1, 10 records. Total amount from sales 2, 1 lakh records. Total amount from sales 3, 1 crore records. Now, which query is going to execute faster among these 3, right? Which query is going to execute faster among these 3? Yes. Total amount from sales 1 or sales 2 or sales 3. Obviously, the first query executes faster, right? Total amount from sales 1 consisting 10 records as compared with the other things, right? Query to query, as the volume increasing, speed is decreasing, right? Even if complexity increases, the speed decreases. Even if complexity increases, speed decreases. If I take, okay, for this also, for complexity increases, speed decreases, right? If you write the SQL queries like this, if you write the SQL queries, right? Sum of amount from sales one, average amount from sales one, standard deviation of amount from sales one, right? Sum of amount from sales one, standard deviation of amount from, just 1 second. Yes, if complexity increases, right, speed decreases, right? If complexity increases, speed decreases. Now try to answer, right? Here, sales one, and sales one, right? All the tables, sales one, same table, right? You're applying sum of amount from sales one, average amount from sales one, standard deviation of amount from sales one, right? Sum of amount, average amount, standard deviation of amount from sales one. Okay. Which query is going to execute faster among these three, right? Everyone. Which query is going to execute faster among these, right? Sum of amount, right? Sum of amount, right?
First one.
Yes. Select, okay, the first query is going to execute faster because the average amount is a two-step process, right? First, sum has to be calculated, next average has to be calculated, right? Standard deviation, lot of internal processing required among these three statements. The first statement executes fast, and next, this is time taking, right? Two-step process takes more time than the first one. This takes a lot of time as come. So here, query to query complexity increases, speed decreases, right? The major drawback with databases. The major drawback with databases, right? Yes. I'm sorry. The major drawback with databases, it can handle only structured data. It can handle only structured data. It cannot handle unstructured data. It cannot handle unstructured data, right? Yes. It can handle only structured, but it cannot handle unstructured data, right? Yes. Okay, now for example, for this, see this example, right? For this, it can handle only structured, it cannot handle unstructured. For example, if you want to take reviews for a particular movie, the table name is reviews. You got a table, two columns, right? You got two columns. User and review. User and review. right? User 1, user 2, user 3, like user 100, right? 100 people, right? First saying, first person saying, okay, if the movie is good, is saying 1, if the movie is bad, saying 0, if the movie is good, saying 1. They're giving the feedback in the form of ones and zeros. Can you write an SQL query? Can you write an SQL query to count the number of ones and zeros? Can we write an SQL query to count the number of zeros and ones? Yes, everyone. I want the sessions to be interactive, right? Everyone. Try to answer if you have got knowledge on SQL. Can I write an SQL query to count the number of zeros and ones? For 100 people, they're giving feedback in zeros and ones. Count aggregation, right? Single grouping, single aggregation. Selector.
Select
Review wise.
review
Wise count.
from
Count aggregation. Count star. From yes.
review.
Reviews table. Group by review, right? Group by review means here the output, if you observe this output, right? Mm. 1 and 0. Review is 1 and 0, right? Ah, 90 people saying the movie is good and 10 people saying the movie is bad. Okay. 90 people saying the movie is good and 10 people saying the movie is bad. But okay, this is fine. But your reviews can't be given in zeros and ones, right? They will give in their own text format, right? Generally, how the reviews will be given in their own text format. First person saying movie is good. Second person saying like movie is not good. Third person saying movie is good. So in this way, they are giving the feedback in their own text format. Now, can you write an SQL query? Can you write an SQL query to say the number of? Can you write an SQL query, right? Movie is good or movie is not good? How many people saying it's good? How many people saying it's not good? Can you write an SQL query now? If you say by using the keyword count, even by using the keyword, we can write, we cannot handle this, right? Databases cannot handle, even if you want to count by using the keyword, right? It gives wrong computation because even not good has got good within it. So it gives wrong computation, right? Yes. So this kind of data cannot be handled. This kind of data can't be handled, right? Yes. So these are the major drawbacks with databases. Now, if you see the Hadoop architecture, right? Later I'll discuss in brief about this Hadoop architecture, storage and processing architecture. Yes. Hadoop doesn't follow client server architecture. Hadoop doesn't follow client server architecture. Hadoop follows master slave architecture, right? Hadoop doesn't follow clients, it follows master slave architecture. Yes. What do you mean by Hadoop cluster? Group of nodes connected in a network. There are two types of nodes. There are two types of nodes. Master node, slave node. There are two types of nodes, master and slave nodes. Just observe this diagram, right? Hadoop follows master's client server architecture, right? Single master, multiple slaves. Hadoop follows single master and multiple slaves. S1, S2, S3, single master, multiple slaves. Yes. Hadoop data is stored in the form of files. F1.txt files are in file format. So you have got many slaves, single master and multiple slaves. Hadoop data is subdivided into smaller parts. Hadoop's data is divided into smaller parts, and they are going to get distributed across multiple systems. What do you mean by slaves? Means multiple systems. Single master and multiple slave systems. Group of systems, nodes connected in a network. We call it as a cluster. So data is stored across multiple systems. Data is processed by multiple systems parallelly. Yes, parallel processing, because of this parallel processing, right? Yes. Okay. So here master node assigns tasks to the slaves. Master nodes are going to assign task T1 task, T2 task, T3 task to the slaves. What are the responsibilities of master? Your data is stored by the slave systems and data is processed by the slave, right? Means your file is divided into smaller parts. That file is distributed across multiple slave systems and are processed parallelly Yes. So in Hadoop group of nodes connected in a network, there are two types of nodes, master and slaves. Master node means it will assign task assignment, assigns tasks to the slave systems. Load balancing, tasks should be given equally to all the slave systems. Fault tolerance. If multiple tasks are executed by multiple slaves parallelly, suddenly if any one slave goes down, then the task of it has to be assigned to any of the other slave. This process is called fault tolerance. And health monitoring. Health monitoring, right? Yes. Yes. So if three tasks are executed by the three slaves parallelly, if any one slave system goes down, then the task of it has to be assigned to any of the other slaves. This process we call fault tolerance, right? Slave node responsibilities. Hadoop, master node, slave node. Slave node responsibilities means storing data and processing data. What is that? Storing data and processing data. What does the slave node does? It stores and It processes the data. So we have seen drawbacks with databases, right? Hadoop advantages. Hadoop advantages, right? Yes. Hadoop advantages means unlimited data storage. Unlimited data storage because of horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. Today, if you are running a business with only 10 slaves, tomorrow your business has increased, your branches have increased, your customers are increased, your data has increased. You need to increase the system slaves, right? Horizontally means horizontally unlimited number of systems can be added. Very high speed processing. Hadoop has very high speed processing because of parallel processing, because your data is distributed across multiple systems, processed parallelly, right? Work done by a single person, work done by 10 persons parallelly take less time, right? In same way here, work done by single system, work done by 20 systems parallelly, right? So very high speed because of this parallel processing. Can handle all varieties of data, structured, unstructured, and semi-structured. Open source, no licensing is required. Hadoop, open source, right? No licensing required. Hadoop, right? Most of it. And commodity hardware means Hadoop can run on any hardware. It doesn't mean that it should have that high configured systems. No, it can run on any configuration. But yes. Now, Hadoop is proven in the market storage point of view and processing point of view. Hadoop is proven in the market storage point of view and processing point of view. Let me give an example, the processing speed of Hadoop, right? Yahoo has taken a table of size 100 TB. Yahoo has taken a table of 100 TB consisting of 1024 columns. What is the task? Sorting based on 16 columns. Sorting based on 16 columns. What is the time taken? What is the time taken, right? Yes, Oracle has taken 3.5 days to process this 100 TB and sorting based on 16 columns. MySQL has taken nearly 6 days to process this. Teradata has taken just 4.4 hours to process this 100 TB. Netija has taken 3 hours, but finally Hadoop just taken 3.4 minutes. The latest version has taken just 1.2 minutes to process it. See the processing speed of Hadoop as compared with the other things, right? So Hadoop is proven in the market processing point of view, right? Yes. Next. So this is the processing speed of Hadoop. Where is this minutes? Where is this hours and days, right? Yes. Hadoop has proven in the market processing point of view. And we have got some couple of queries right here. Why databases like Oracle cannot support unlimited storage? Why databases like Oracle cannot support unlimited storage? Databases, right? They have got some limit on the number of systems. In the real time also, databases have got some limit on the number of slave systems. See, for example, why databases like Oracle? Why only Hadoop, right? Max limit on number of slaves. Oracle max it can go with 256 slaves. MySQL can go with 54 slaves, but MySQL Express can go with 256. SQL Server, DB2, all this they can go with 256, right? But specialized databases like Teradata, Netija, Vertica, they can go with 512, right? Teradata and Netija currently going with 1024 slaves. But still, we cannot say this as unlimited data storage. Unlimited data storage. Limited. Once they get filled, they cannot support data further. Once they get filled, they cannot support the data further, right? Yes. Right. But there is no limit on the number of slaves that Hadoop can have, right? So here, these databases and specialized databases, they have got some limit on the number of slaves. But there is no limit, there is no limitation on the number of slaves that Hadoop can have. It can go with any number of slaves. When Yahoo first time implemented Hadoop went with 4,000 slaves. Currently, Yahoo going with 12,000 slaves. Okay. Currently, Yahoo going with 12,000 slaves, right? Yes. Facebook when first time implemented Hadoop. Facebook when first time implemented Hadoop went with 8,000 slaves. Currently, Facebook going with 42,000 slaves for storing its data, right? Yes. Right. How exactly data stored and processed in Hadoop, right? Yes. So understood. So Hadoop is prevent storage point of view with no limitation on the number of slaves. It can have thousands of slaves. No limit on the number of slaves that Hadoop can have, but there is a limitation on the databases. You have seen the speed of Hadoop as compared with other databases. And we have seen, right, the storage point of view, Hadoop can go with unlimited number of steps, but databases, they have got some limit, right? And how exactly data stored and processed? How exactly data stored and processed? In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. Again, each file is subdivided into blocks. In Hadoop, data is stored in the form of files. Each file is again subdivided into blocks. Default block size. So default block size is 64 MB. Latest versions, like it can go with 128 MB, right? Fine. Hadoop data is stored in the form of files. The files again subdivided into smaller parts called blocks. Each block, what is the size? 128 MB, right? f1.txt, for example, there is a file f1.txt, 200 MB. In Hadoop, there is a file f1 size, assume that the size is 200 MB. Default block size, assume it is 64 MB. Into how many blocks this is divided, into how many blocks this file is divided means number of blocks equal to size by default block size. Size by default block size. Size by default block size, right? Size is 200 by 64. How many blocks? 4 blocks. Means B1 block, B2, B3, B4. B1 of 64 MB, B2 of 64, B3 64, B4 of 8 MB only. 56 MB free here. So B1 stored in system 1, B2 in slave 2, that is B3 in slave 3, B4 in slave 4. So 4 blocks are stored on 4 systems and are processed parallelly. But if you got one more file, f2.txt, right? f2.txt, 192 MB. Default block size 64 MB. Means this file is divided into 64, 64, 64, right? Blocks. How many blocks means? 3 blocks. B5, B6, B7. B5 of 64 MB, 64, 64. Stored in 3 systems. Here you have got a query, right? 56 MB free in B4. Why this B5 data is not stored in B4? When 56 MB is okay. Why B5 data is not stored in B4, right? Okay. So why this B5 data is not stored in B4? Because if you try to retrieve this f1.txt, we need to combine B2, B1, B2, B3, B4. But if B5 data is stored in B4, you will get 256 MB, but actual file size is 200 MB. So every file will have its dedicated number of blocks. Observe. So if I want to retrieve f1.txt, if B5 data is stored in B4, 64, 64, 64, 8 MB plus 56 MB. 256 MB, but actual file size is 200 MB. So when we are retrieving f1.txt, we are getting a part of f2. If B5 data is stored in B4, the other file data also will be retrieved. So every file should have its own blocks. Every file should have dedicated number of blocks. In a single block, no 2 files data to be stored. every block has equal value except the last block. Every block has equal value except the last block, right? 64, 64, 64, except the last block has got 8 MB, right? So just now observe this, how exactly the data storage and processing happens. If number of blocks equal to number of slaves, how many blocks? Assume 3 blocks equal to 3 slaves. B1, B2, and B3. Slaves how many? S1, S2, S3. So high speed, we achieve high speed, full parallelism. Full parallelism, right? Yes. If you got f1.txt, f1.txt size is like one, assume this file size is 192 MB. This file is again subdivided into smaller parts. Assume default block size equal to 64 MB. So into how many blocks it is divided? 192 by 64. You will get how many? 3 blocks. 3 blocks means like B1, B2, and B3. How these 3 blocks are stored across this master and slave, right? S1, S2, S3. B1 here, B2 here, B3 here. B1, you think that you got some 10 lakh records, B2 10 lakh records, B3 10 lakh records. 10 lakh, 10 lakh, 10 lakh, right? Yes. F1.txt divided into 3 blocks. B1, B2, and B3. B1 stored in S1, B2 in S2, B3 in S3. So this is master node or name node we call, right? Master node stores metadata, but actual data is stored within the slaves, but only the metadata, data about data, which blocks in which slaves, this information, blocks information, everything stored in the master, but actual data stored within the slaves. Data processing. Data processing, right? Yes. In Hadoop, always, okay, for example, job is process f1.txt, always job divided into tasks. In Hadoop, number of tasks always depends on number of unique blocks, number of unique blocks. F1.txt equal number of tasks equal to number of unique blocks. How many blocks here? 3 blocks. 3 blocks means 3 tasks. T1, T2, and T3. T1, T2, and T3. Yes. So your job is to process f1.txt. f1.txt, it has got divided into three tasks, T1, T2, and T3. T1 for executing, right? T1 for executing B1, 10 lakh records. T2 for executing B2, T3 for executing B3, 10 lakh records, 10 lakh records, right? Yes. T2 for executing B2, 10 lakh, T3 for executing B3, 10 lakh records. And who should execute this T1 task? Who should execute this T1 task? Means executing B1 means S1 only should execute, right? Because B1 10 lakh records is stored in S1. S1 only should execute, right? Yes. Who should execute this T2 task? S2. Who should execute this S3? T3 task by S3, right? T1 task executed by S1, T2 by S2, T3 by S3. T1 task by S1, T2 by S2, T3 by S3. Okay. So here three tasks, T1, T2, T3. T1, T2, T3 are the three tasks executed by three slaves, parallelly. Yes. So yes, how exactly the data is getting stored, how exactly the data is processed, right? So this is what storage, how the data is stored. It's a file divided into blocks. The blocks are stored across the multiple slaves. And how it is processed means into three tasks executed by three slaves parallelly, right? When T1 task is assigned to slave 1, T2 to S2, T3 to S3. When three tasks are assigned to the three slaves, suddenly if any one system goes down, right? Then if any one slave goes down, then 10 lakh records are lost. 10 lakh records are lost. So how Hadoop is able to overcome this kind of thing, right? 10 lakh records are lost means huge loss, right? 10 lakh records are lost means huge loss. And T2 task also will be failed. So Hadoop is coming with a concept called replication and fault tolerance. It's coming with a concept called replication and fault tolerance. Replication and fault tolerance. Replication, nothing but duplication. Replication is nothing but duplication. Duplication, right? Yes. Default number of replications. default number of replications. Replicas. Default number of replications or replicas in Hadoop are 3. Default number of replications or replicas are 3. Okay. What do you mean by this replication and replicas, right? Yes, I'll just say right. Yes. Yeah, 1 second. Yeah, default number of replications are 3. What do you mean by this replications and fault tolerance means? Right. f1.txt, if the file size is 192 MB, assume the file size, whatever might be the ones, MB or GBs or TBs, into default block size. Assume the default each block size. If it is 64 MB, we can provide our own block size. We can provide our own block size, right? We can configure our own block size. Default block size is 64 MB. Into how many blocks? Number of blocks, right? 192 by 64. 192 by 64, right? 3 blocks. Three blocks means B1, B2, and B3. B1, B2, and B3, right? B1, B2, and B3. B1 replicated by 3 times, B2 replicated by 3 times, B3 replicated by 3 times means duplications. Totally 9 blocks. How these 9 blocks are going to get stored across this? How many systems? Slave systems, right? S1, S2, S3. B1, B2, B3. B1, B3, B2. B3, B1, B2. F1.txt. F1.txt, right? F1.txt, right? B1, B2, B3. B1 stored in S1, in S2, and S3. B2 also stored in S1, S2, and S3. B3 also stored in S1 or S2 or S3. B1 stored in S1, S2, S3, B2 stored in S1, S2, B3 also stored in S1, S2, S3. So how this data storage? Now data processing, right? Data processing, right? Yes. Job is to process f1.txt. Job always divides into tasks. Number of tasks in Hadoop always depends on number of unique blocks. Number of unique blocks. Number of tasks always depends on number of unique blocks. How many unique blocks? 3 blocks. Don't say 9, right? It's 3 blocks. It's 3 blocks. T1. Okay. 3 blocks means 3 tasks. T1, T2, and T3. Job to process f1.txt divided into 3 tasks, T1, T2, and T3. T1 for executing B1, T2 for executing B2, T3 for executing B3. T1 for executing B1. Who should execute this T1? T1 is for executing B1 is present in S1, B1 is present in S2, B1 is present in S3. Means S1, S2, or S3. All these three can execute, right? T2 task also can be executed by S1, S2, S3. T3 also can be executed by S1, S2, S3, right? Assume master node has selected for executing T1, it has selected S1 only. For T2, it has selected S2 only. T3, S3 only it has selected. 3 tasks assigned to 3 slaves. T1 task, T2 task, T3 task. While executing 3 tasks by the 3 slaves, suddenly if any one slave goes down, right? Still there is no data loss, right? B1, B2, B3 blocks still available in slave 1. B1, B2, B3 blocks still available. Previously, there was a data loss if there is no replication or duplication. The same, okay, there is no data loss, and this T2 task will be assigned to either T1 or T3. They will be performing 2 tasks. Okay, fine. There is no data loss, and the T2 task also it's not failed. Job also it's not failed. Job also is not failed, right? Yes. So 3 tasks. Okay. This T2 task will be assigned to T1 or T3, right? Yes. So here I got some query, right? What is the criteria followed in assigning the T2 task to either T1 or T3? And what is the criteria followed in assigning the T1 task? The T1 task to why S1 only given priority in assigning this T1 task? Why this T2 task is assigned to S2 only? Why not to S1? What is the criteria followed in assigning the task to the slaves. Next. So here there is a 4 steps criteria, right? Just understand this 4 steps criteria in assigning the task to the slaves. The same thing, I'm providing the notes for what we have discussed. What is the criteria followed in assigning? What is the criteria followed? In assigning the task to the slaves? 4 steps criteria, right? Master node selects the slave which is highly configured among S1 or S. So here, observe this. S1 executing T1, S2 executing T2, S3 executing T3. Suddenly, this S2 system is down. Then T2 task should be assigned to S1 or S3. What is the criteria for means 4 steps criteria? Master node selects the slave which is highly configured among S1 or S3. If both are highly configured, right? If both are highly configured, then master node selects the slave which is more ideal, more free. If both the slaves are free, S1 or S3, master node selects the slave which is nearest to it. Master and slaves, master can be in one country, slaves can be in different countries. Master in one state, slaves can be in another states. In master in one city, slaves in other cities. Otherwise, everything all at the single place. If both are at the same, both are equally near, assume both the slaves are equally near. Master node selects the slave which has good health status. Good health status means even though they have got good configured, right? But the health condition status, right? Now and then the system may go down, right? If both have got good health status, in the extreme case, it selects any one slave randomly. What do you mean by fault tolerance? If multiple tasks are executed by multiple slaves, suddenly if any slave goes down, then the task will be reassigned to other slave. This process is called fault tolerance model, right? Yes. Fine, right. So this is what introduction to this, right? How exactly data stored and processed, and what is Hadoop? What are the services of Hadoop? Advantages of Hadoop, drawbacks with databases, how exactly data stored and processed. Just I was showing you, right? So yes, yes, we'll have a break for 10-15 minutes, right? We'll have a 15 minutes break and we can rejoin. I'll discuss Hadoop architecture, right? So we'll discuss, okay. Before that, I'll be just showing you the course content, right? What we'll be discussing as part of this. Just you can go to this course content. Right. Big data Hadoop, HDFS, Hadoop distributed file system. MapReduce, Scoop SQL plus Hadoop for import export operations. Yarn, yet another resource negotiator. Yes, NoSQL database. Yarn, yet another resource negotiator. How this processing is going to happen. NoSQL database, right? What is not only SQL? What is the problem with RDBMS? Key value store, introduction to Cassandra, integration with NoSQL data, and HBase one NoSQL database I'll be discussing. So one more important Hadoop component like Hive I'll be discussing in brief. And next, PySpark introduction, PySpark RTD computation, persistence features. My more concentration will be on the Spark with Python, PySpark, right? PySpark RTD, PySpark persistence, PySpark core computations, groupings, aggregations, various actions and transformations, PySpark SQL data frame, RTDs, right? SQL data frame, RTDs creating empty set row class with column renamed, where drop, group by join, union by name, map, flat map, right? PySpark SQL functions, PySpark built-in functions, one by one built-in functions of PySpark in brief, and PySpark external sources, integrations with different sources like Hive, MySQL, working with JSON, CSV files, right? Adding and removing, dropping, renaming columns, writing data to deployment modes, PySpark applications, and PySpark streaming and integration with Kafka, and the deployment, right? So this is what I'll be discussing in brief. So it's like 12 weeks. It's like nearly 3 months we'll be discussing on this in brief, in depth, right? Yes. Correct. So if there is a link forwarded in the chart, right? There is a link forwarded in the chart panel, right? Yes. You can see a link, right? There is a Zoom meeting, right? The link, once again, I'm posting that link in the chart now. You can just follow that link. You can join the session, right? There'll be one more, just we'll have a break for 15 minutes and we'll continue Hadoop architecture, Hadoop storage and processing architecture. Right. Just one link I forwarded. You can follow that link. Okay, we'll join 10-15 minutes of break and we can join the session, right? We'll discuss more on this. We'll go for 1.5 hour more, right? Yes. Everyone. Just in the chart panel, right? I forwarded a link. Once again, you can see that, right? I'm forwarding once again. The link you can forward. Just to take 10-15 minutes of break and rejoin the session using that link, the new link, right? Follow that link. Right? Okay, fine. So we'll be seeing a Hadoop architecture, Hadoop storage architecture, processing architecture, step by step. Right, the storage and stop for now. We'll have a break and we'll continue. Yes, follow that link, copy that link and join that link, right? Any queries before that? Anyone? Later to this introduction to this Hadoop. Fine. Okay.